Hey, looking at the graph of, hey, the bell's ringing. Looking at the graph of sine x and cosine x in this function. We'll start with y equals sine, oh, triangle man. Actually, that's triangle pumpkin. I forgot. Today's Halloween, so we have triangle pumpkin today. All right, okay, y equals sine x. When you're graphing, first we do graph in radians. We don't graph in degrees. So I'm going to kind of go ahead and white out all of these degrees in the unit circle here. This unit circle, I'm just going to kind of use it as a reference to help us get this first graph out of the way. So we're going to ignore degrees. We always graph in radians in math. And when you label your axis, we're going to label a little bit weird. The values of sine, if you remember, are the y coordinates in your unit circle. So we're going to be looking at all of these y coordinates. And when we're graphing, our x-axis is going to be labeled with the angles. And we're only going to graph the sexy points. Now, graphing y equals root 3 over 2 is going to be really tough. So when we graph, we're going to start at an angle of 0, and that's going to be the origin. Then we're going to move over, and I'm going to look at only the nice sexy coordinates, which really happens only at your 90 degree or pi over 2 angles. So I'm going to label my x-axis in intervals of pi over 2. Pi over 2. Another pi over 2 puts me at pi. If I go another 90 degrees, that puts me at 3 pi over 2. And another 90 degrees puts me at 2 pi. And then I could also go backwards. I could go backwards pi over 2, so negative pi over 2. We can go to the left side. I can go backwards pi. And if I go backwards pi, that puts me over here. I could do negative 3 pi over 2. And I could do negative 2 pi. So we're going to graph with that scale on our x-axis, and then my y-coordinates are going to be the values of sine at those angles. So at 0, sine is 0, so I'll plot the point 0, 0. When I get to pi over 2, my sine is 1, so I'm going to go up to 1 at pi over 2. When I get to an angle of pi, my sine is 0, so I'm going to plot 0. When I get to 3 pi over 2, when I get to 3 pi over 2, I'm at negative 1. And when I get to 2 pi, I'm back at a y-coordinate of 0. And this is what we call one period of the graph of sine x. And it's nice and smooth. Make sure you connect it with waves. One of my pet peeves is when people draw these graphs with zigzags. For the love of all that's holy! What's up with all the announcements? By the way, as I was saying, do not connect them with zigzags. These are nice, rounded, smooth graphs. They are not pointed. It's kind of a pet peeve. So when you graph, make sure that you connect them. It's nice and smooth and wavy, just like that. We can also go backwards. If I go backwards pi over 2, we're at negative 1. And really what we do is we just follow that same wavy trend. And this is going to give us 2 periods of the graph of y equals sine x. So there's our graph of sine x. You need to know just your basic graph of sine x, because when we start transforming, you're going to start with this and then move it and shift it and squeeze it and stretch it and do everything else that we do with transformations. So you need to know just this basic graph of y equals sine x. And then we're also going to do the basic graph of y equals cosine x. Again, we're not going to deal with radians, with degrees, so ignore the degrees. We always graph in radians in calculus, in pre-cal. In any math class, you graph in radians. And we are, let me go ahead and set up my axes. Pause while I do this. All right, my axes are set up, and I'll label with the angles. Remember, we do angles in radians, so those go on the x-axis. And for cosine, if you remember, your cosine is the x-coordinates. And again, we're only going to look at the nice, clean 90-degree angles. So I'm not going to bother highlighting my x-coordinates for those other angles. I'm only going to graph at my 90-degree angles. And that would give me, at 0, at an angle of 0, my cosine is 1. So cosine actually starts up here at 1. At an angle of pi over 2, cosine is 0. At an angle of pi, my cosine is negative 1. So at pi, I'm at negative 1. 3 pi over 2 is 0. And 2 pi is positive 1. And cosine has this nice, smooth, wavy graph. It's actually the same shape as sine. It just starts in a different place. If you continue to the left, at these angles, we just continue that same pattern. It's a nice, smooth, wavy graph. It's not pointed. Please don't connect with zigzags. And that is your basic graph of cosine x, and you need to know what the graph of cosine x looks like, because we will stretch and squeeze and move this around, and we're always going to start with this. This is kind of like our home base for graphing trig functions. Okay, so there's our basic graphs of cosine x, and this is the basic graph of sine x. You need to know those. If we're going to do some transformations, well, for this one, number 3 here, we're actually going to start with that same graph of y equals sine x, except we have a transformation here. I have 3 times my function. That 3 is not inside with the x. So if you remember your transformations, if it's 3 times on the outside of the function, we're going to multiply our y coordinates by 3. Some of you, if you have a different teacher, your teacher may call that a vertical stretch by a factor of 3. That is always confusing to me. I do multiply the y coordinates by, hey, I forgot my words on, my factor. So multiply the y coordinates by 3. Some of y'all out there in the wherever other places, you may hear it as a vertical stretch. So we're going to start with y equals sine x. So I'm actually going to go back to my sine graph, and I'm going to import my graph for sine x. So let me do that real quick. There we go. Now this is my graph of sine x that we did just a minute ago. Now if I multiply my y coordinates by 3, then I will look at my y coordinates, and the highest I get is 1, and the lowest I get is -1. If I triple those, instead of going up to 1, I'm going to go up to 3. So my max is going to be way up here, and if here my y coordinate is 0, my zeros will stay in the same place. Here my y coordinate is -1. If we multiply that by 3, we're going to go down to -3. And same thing for these. This one's going to go down to -3. This one's going to go up to +3. This one's going to stay at 0. And what this graph does is it changes what's called the amplitude. This is going to be a very tall graph. The x-intercept stayed the same place, but when I multiplied my y's by 3, it suddenly made this thing much taller, and it appears to be much skinnier as well. So there's our graph of y equals 3 sine x in blue. Good, 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 good. So number in front, that's going to change how tall it is. Let's look at, here we have y equals cosine of 2x. If something is inside with the x, which that 2 is, it affects the x coordinates and does the opposite. So it says 2 times x in the equation, but we're actually going to divide the x's by 2. Some of you out there, some of our strangers who are spying in on our lessons, may hear that as a horizontal compression. And again, that verbology, trying to sound smart, confuses me. So I just like to think of it as dividing the x's by 2. We're going to start with y equals cosine x. Let me go get my cosine x graph and bring it in. Here's the cosine graph. This is just regular y equals cosine x, nothing funky going on there. So this is y equals cosine x, but I need to divide my x coordinates by 2. Now these are going to be a little bit trickier. So now I'm looking at my x coordinates. Let's start right here. My x coordinate is 0, so that's going to stay where it is. This x coordinate is pi over 2. So if I divide that by 2, so I'm going to go over into thinking land here, and we'll do our calculations here. Pi over 2 divided by 2 is the same thing as pi over 2 times 1/2, which is pi over 4. So this pi over 2 point is actually going to move into pi over 4. It's going to move halfway to the y-axis, pi over 4. Here I am at pi. If I divide my pi by 2, my x-coordinate is pi, well, that's just pi over 2. So that point is actually going to move over to pi over 2. 3 pi over 2, if I divide that by 2, so 3 pi over 2 divided by 2 is going to end up being 3 pi over 4. So this x-coordinate is going to move to 3 pi over 4. And 3 pi over 4, if you think about your unit circle, is between pi over 2 and pi. That's going to be about right here. 3 pi over 4. And 2 pi divided by 2 is going to be 1 pi. So this graph gets squeezed in by a factor of 2. Still nice and wavy. And all of these points are going to do the same over here. All of these are going to move in closer to the y-axis. If you divide those x-coordinates by 2. And this is going to give us a skinny graph like that. So the green graph here is going to be y equals cosine of 2x. So what we just did there were that was a couple of transformations where you squeeze or you stretch in certain ways. I used some words there that we need to be familiar with. They are period and amplitude. Your period is simply the length of one full cycle of the graph. If you look at, say, sine x, I can complete one full cycle for sine x. I go up, then I come down, then I go back up, and then that cycle repeats. Well, that happened from 0 to 2 pi. That distance was 2 pi, so the period is 2 pi. And the same thing for cosine. I completed one cycle from 0 to 2 pi, so your period is 2 pi. It was already labeled here, but I wanted to write it. The amplitude is the distance from the middle to either the max or the min. So that's going to be from the middle to the top, and the amplitude is this distance. That's your amplitude. And if you don't transform your graph, your amplitude is going to start at 1. Now, if you do like y equals 3 sine x, it changes your amplitude. And the way you find the amplitude and the periods simply by looking at the equation, regardless of sine or cosine, your amplitude, I kind of have it upside down, your amplitude is determined by the number in front. So if I have like 5 cosine of something or 5 sine of something, the amplitude is going to be 5. Amplitude is always measured with a positive number, so even in a problem like -3 cosine x, the amplitude would be +3. Your period's a little bit trickier. Whatever the coefficient is of x, you divide 2 pi by that number, and it gives you the period. And then a little note at the bottom, if your leading coefficient is negative, if a is negative, then it flips your graph upside down. So this is how we find period and amplitude, and we're going to practice that a couple of times here. I simply want to find the period and amplitude for these two graphs. Amplitude is the easy one. Amplitude is simply determined by the number in front, and it's always positive. Amplitude is always positive. You take the absolute value of that number. If the number is negative, like it is here for number 6, that just means your graph is going to start upside down, but it does not affect the amplitude. So the amplitude is 2 or 5. Period is a little bit trickier because period, you do 2 pi divided by the coefficient of x. So period for number 5 would be 2 pi divided by 4, or that reduces to pi over 2. For number 6, it's 2 pi divided by 3, which does not reduce any. So that's how you find period and amplitude. And it's almost easier to graph thinking of period and amplitude versus thinking of your transformations. So let's try graphing based on period and amplitude. Hopefully this won't be too much longer. I see sine x, and when I see sine x, I automatically visualize the original graph of sine. Now there's a -3 and a 2, which is going to change the shape, but I need to think about what the graph of sine looks like. So I'm going to go pull in my graph of sine. Let me pause the recording for a second. Here we go. There's my graph of sine, and that's just kind of floating around in the back of my head, just so I have an idea of what the graph of sine x looks like. And I'm going to start by finding the amplitude and the period. My amplitude is going to be 3. My period is going to be 2 pi divided by my coefficient, which in this case is 2, and 2 pi divided by 2 is simply pi, so that's my period. And when I graph sine and cosine, rather than graphing the original and then dividing or doing the transformations, I'm going to go ahead and tackle my amplitude and period on the front end. So what I'm going to do, I know my general shape of sine x starts at the origin. It goes up, then comes down, and goes back up. So this is my general shape of sine x. Now I don't want to stop here because you have to label how high you're going, and you have to label, I call your 4 crucial points, your max, your x-intercepts, your min, and your other x-intercept. I want you to label those. Now there's one thing that I've already messed up. This is a negative sign, so it's going to flip the graph upside down. So rather than start at the origin and go up, I'm going to start at the origin and go down. So let me throw this away. I'm going to start at the origin and go down, come back up, go up, come back down. Now that's kind of a crappy looking graph, but that's what it's going to look like. Then I start thinking about amplitude and period. If my amplitude is 3, that means my peak up here has to occur at a y-coordinate of 3. So I'll label my y-axis, letting me know that I'm going up to 3 and down to negative 3. Then if my period is pi, that means I start at 0 and I finish at pi. So that x-coordinate is pi. And then to find my remaining ones, they're always spaced evenly. So this point in the middle is going to be it's going to be exactly half of pi. So I kind of go into thinking land over here. We'll see if my period was pi, then I'm going to divide that by 2, and that doesn't reduce. Pi over 2 is simply pi over 2, and that's what this x-intercept is going to be. Pi over 2. Oh, then my next point, this minimum, this x-coordinate is exactly half in the middle. So again, I'm going to take that x-coordinate, pi over 2, and I'm going to divide it by 2, which is the same as pi over 2 times 1/2, which ends up being pi over 4. So our x-coordinate here is pi over 4. And this number right here, the first x-coordinate, that is how you count. This is what you count by. Now that's very weird, in addition to my weird W, what you count by. And what I mean by that, this is going to be a long video. Yep, it's already 16 minutes. That's not good. So this is what you count by. And what I mean by what you count by is this is 1 pi over 4. If I keep counting by pi over 4, so 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. If you think about that, 1 pi over 2, or 1 pi over 4, this is 2 pi over 4 right here, which reduces to pi over 2. This one is going to be my third pi over 4, which doesn't reduce. This one is 4 pi over 4, and the 4's actually cancel, leaving you with just pi. So this is how we're going to graph. We consider the amplitude and the period on the front end, and then you do the division to find out what your x-coordinates are, and amplitude tells you how far up and down you're going to go. Okay, let's try one with cosine. Let's try one with cosine. So we have y equals 4 cosine of negative x over 2. Okay, 4 cosine of negative x over 2. Okay, I'm going to pull in my graph of cosine x so I can think about what it looks like. Okay, so there I have y equals cosine x kind of floating around in my head up here. So there's y equals cosine x. And I'm going to identify my period and my amplitude. Well, amplitude is easy. Amplitude is just going to be 4. So instead of going up to 1, this graph is going to go up to 4. My coefficient of x, I'm going to change the way this is written. This is 4. Ooh, can I change that? I don't want this to be negative. I don't know why I put a negative in there. I don't want to put a negative in here. Let's change the guns around a little bit. Let's change that to just x over 2. My bad. My bad. We'll tackle negatives later. So this is the same as 4 times the cosine of 1/2 x. So I changed my graph. It's 4 cosine of x over 2. That's 1/2 x, which means my period is going to be 2 pi divided by this number right here, 1/2. And if you divide by 1/2, that's the same as multiplying by 2. So my period actually ends up being 4 pi, which is going to make this kind of sexy. So let's graph. Let's graph. I know cosine starts up high, then comes down and finishes up high. This is a positive cosine, so it's not going to flip. So I'm going to start up high. I'm going to come down. And then I'm going to finish up high. Remember, it's nice and smooth. And then my period from start to finish was 4 pi. So I know this x-coordinate is 4 pi. And then we need to label the x values of any x-intercept and the minimum. And we simply start dividing by 2 to get all of that. So if I ended at 4 pi, this point right in the middle, well, I'm simply going to take 4 pi and divide that by 2. That gives me 2 pi. So this x-coordinate is 2 pi. And then I'll divide that by 2 to get this x-coordinate. So 2 pi divided by 2 is simply pi. And that tells me how to count. So each little tick represents 1 pi. So 1 pi, 2 pi, 3 pi, and 4 pi. And that gets my period. And then I need to take care of my amplitude. That's really tough. Instead of starting at 1, we're going to start up here at 4, and we're going to go down to -4. So that is how we're going to graph this one. and this is the graph of 4 cosine of x over 2. I think I'm going to stop there. I had a few other graphs. I wanted to talk about horizontal shifts and vertical shifts. We may just talk about those in class because this is already 20 minutes and y'all are probably trick-or-treating anyway. So I will see y'all in class sometime in the future. Who knows?